Greetings of the day. Today we will start a new topic from the same chapter, chapter 4, Structure of the Atom. Class 9, Agido Academy Education. Please like, share and subscribe the channel. Don't forget to click the bell icon so that I can send you notification for every video update. Students, we already have discussed point number 6, numerical based on electrons, in my previous video. Today we will start the point 7, discovery of protons. So we will go further. Please kind attention all students. Watch the video carefully and repeatedly to understand properly. Stay tuned for all video updates. Please comment in the comment box for all your doubts in this chapter. I will make video for all questions raised by students. Please don't skip the video, otherwise you will miss the important part. All the topics are explained thoroughly, very carefully and clearly. Still, if any single student is unable to understand any part of the video, please let me know in the comment box. Now start discovery of proton. The existence of protons in the atoms was given by Goldstein. E. Goldstein, a German scientist, repeated the Thompson's experiment by modifying the discharge tube. He used a perforated cathode and it was placed somewhere in the center of the tube and not at the end. Hydrogen gas was enclosed in the discharge tube and the experiment was performed in the same way as was done by Thompson. When electricity was passed at high voltage through a gas at a very low pressure in a discharge tube, streams of heavy particles were given at anode, means positive electrode. The streams of particles are called as anode rays. These particles were positively charged and the anode ray particles depend on the nature of the gas taken in the discharge tube. Note, the mass and charge of the anode ray particles depends on the nature of the gas taken in the discharge tube. They are named as protons, which are positively charged, and it is found in all the atoms. Protons are represented as P plus or positive charge. Mass of proton is equal to the mass of hydrogen atom. Therefore, relative mass of proton is 1 U. Absolute mass of proton is 1840 times that of the electron. Charge on electron is equal and opposite to the charge of the electron. So the charge on proton is equal to 1.6 into 10 to the power minus 19. Relative charge is plus 1 and the absolute mass of electron is 1.607 into 10 to the power minus 24. It means a proton may be defined as that fundamental particle which carries 1 unit positive charge and has a mass nearly equal to that of a hydrogen atom. Okay, student? Now the next, do atom rays originate from anode? Cathode rays originate from the cathode. We already have discussed in my previous video, whereas anode rays are not produced from the anode. They are produced from the gaseous atoms by knockout of the electrons by high speed cathode rays. Now look at here this diagram. This is the proton or anode ray, formation of positive rays or anode rays. This is the discharge tube, air at very low pressure, green glow, cathode, anode, and to vacuum pump, high voltage generator. E. Goldstein, a German scientist, repeated J. Thompson's experiment by modifying the discharge tube. He used a perforated cathode and a hydrogen gas at low pressure was placed inside the discharge tube. On passing high voltage current between the electrodes, it was found that some rays emitted from the side of the anode passed through the holes in the cathode and produced green fluorescence on the opposite glass wall coated with zinc sulfide. These rays were named anode rays or canal rays. Now the first question, what are the properties of anode rays? They consist of positively charged particles. They are deflected by electrical and magnetic fields. The deflection of anode rays is less compared to cathode rays. Anode rays comprise of heavier particles than cathode rays, which are electrons. Second question, what is wrong about anode rays? Anode rays consist of positive ions formed by ionization of gas molecules. The charge, which is denoted by E, on positive ion depends upon the number of electrons knocked out from gas molecules. Hence, E by M will not be constant. Are anode rays visible? An anode ray ion source typically is an anode coated with the halide salt of an alkali or alkaline earth metal, that is halogen group. Applications of a sufficiently high electrical potential creates alkali or alkaline earth ion, and their emission is most brightly visible at the anode. What is the charge of anode rays? Anode rays consist of material particles. Anode rays are deflected by electrical field towards negatively charged plate. This indicates that they are positively charged. How are the anode rays discovered? The stream of positively charged particles are called anode ray or positive rays or canal rays. In 1886, Goldstein performed a discharge tube experiment using perforated cathode. These rays were found to consist of positively charged particles and were called anode rays or positive rays or canal rays. What are canal rays in very short? Canal rays are the rays of radiation which emerges in a tube which has been discharged and has the property of low pressure with voltage of high value conditions. Explanation: this canal ray are thus positive in nature of charge. Are cathode rays visible? Cathode rays are invisible, but their presence was fast detected in earlier vacuum tubes when they start the glass wall of the tube, exciting the atoms of the glass and causing them to emit light, a glow called fluorescence. This glow light is called fluorescence. Why cathode rays are green? Cathode rays travel from the cathode at the rear of the tube, striking the glass front, making it glow green by fluorescence. A metal cross in the tube caused a shadow demonstrations demonstrating that the rays travel in straight lines. The pink glow is caused by cathode rays striking residual gas atoms in the tube. Are anode rays heavier than cathode rays? Anode rays are heavier than cathode rays. Explain what is canal rays. The beam of rays which travel in a direction away from anode towards cathode when gas is taken in a discharge tube is subjected to the action of high voltage under low pressure is known as canal ray. These rays were positively charged radiation which ultimately led to the discovery of another subatomic particles. Now, this is the picture of formation of anode ray or positive ray. Now, the next topic, discovery of neutron. James Chadwick in 1932 discovered the neutrons, which are the neutral part found in the nucleus of an atom. Second, atoms of all the elements contain neutrons except ordinary hydrogen atom, which does not contain any neutron. Third, symbol for neutron is small n. This number 4, this subatomic part is not present in hydrogen atom. Mass of a neutron. The relative mass of neutron is 1U. The mass of neutron is equal to the mass of proton. Second point, the absolute mass of neutron is 1.6 into 10 to the power minus 24. Charge of a neutron. Neutron has no charge. Second point, it is electrically neutral. Atomic mass of carbon is equal to mass of 6 protons plus mass of 6 neutrons. So that means 6 plus 6 is equal to 12U. Now the next point or topic is Thompson's models of an atom or of the atom. So students, we will go further. First of all, we discuss structure of atom. The discovery of electrons and protons made by Thomson and Goldstein along with their co-workers brought a revolution in the field of science, particularly chemistry. The Dalton's concept of indivisibility of an atom was discarded. Electrons and protons were regarded as the main particles associated with every atom. Now, the major challenge before the scientist was to determine the relative position of these fundamental particles in an atom. We are briefly discussing the contribution made by different scientists in this direction. So now, Thomson's models of an atom. Thomson's was the first scientist to prepare a model for the structure of an atom. At that time, only electron and proton were discovered. Thomson's models of the atom is similar to that of Christmas pudding or cake. The electrons are like dry fruits which are embedded on the base, which looks like a positively charged sphere. Thomson's model can also be compared to a watermelon. According to this model, an atom consists of a sphere of positive charge with negatively charged electrons embedded in it. The positive and negative charge in atom are equal in magnitude, due to which an atom is electrically neutral. It has no overall positive or negative charge. Thomson's model explained the electrical neutrality but failed to explain the various experiments carried out by other scientists like Ruderfort. This is the model of Thomson's models of an atom. This is the diagram or picture. So the sphere part, it's a positively charged, this is proton, and negatively charged electrons, those part is negative or minus, this is electron. This is called the Thomson model of an atom. So we will go further. Please kind attention all students. Watch the video carefully and repeatedly to understand properly. Stay tuned for all video updates. Please comment in the comment box for all your doubts in this chapter. I will make video for all questions raised by students. Please don't skip the video, otherwise you will miss the important part. All the topics are explained thoroughly, very carefully and clearly. Still, if any single student is unable to understand any part of the video, please let me know in the comment box. Now, limitation of Thomson's atomic model. Thomson's atomic model failed to explain how the positive charge holds on the electrons inside the atom. It also failed to explain an atom's stability. First. Second, the theory didn't mention anything about the nucleus of an atom. Third point, it was unable to explain the scattering experiment of Rutherford. Now, what is the conclusion? Even though Thomson's atomic model was inaccurate and had a few drawbacks, it provided the base for several other atomic structure models afterward. It is one of the foundation models that led to significant and revolutionary inventions later. Now, the next topic, Rutherford's experiment, a discovery of nucleus. Rutherford model of an atom. The major contribution is knowing the relative position of electrons and protons in an atom was by Ruderfort, a scientist from England. He performed the famous alpha particle scattering experiment in the year 1911. For this, he selected a thin foil of a heavy gold metal. It was about 1,000 atoms thick. He bombarded the same with high speed alpha particles. These are in fact positively charged helium nuclei. So now we will explain alpha particle. Alpha particle is a positively charged particle having 2 units of positive charge and 4 units of mass. It is actually helium ion. Its symbol is He plus 2 or 2 plus or plus plus. Third point, Rutherford's alpha particle scattering experiment led to the discovery of small positively charged nucleus in the atom which contained protons and neutrons. When first moving alpha particles are allowed to strike a thin gold foil of about 1,000 atoms thick in vacuum, it is found that first, most of the first moving alpha particle pass straight through gold foil. Second, some of the alpha particles were deflected by small angles. Third, about 1 out of every 12,000 particles appeared to rebound. Now, what is the conclusion? Most of the space in the atom is empty. The positive charge of the atom occupies very little space. The electrons revolve around the nucleus in circular paths. All the positive charge and the mass of the atom were concentrated in a very small volume at the center. It shows the presence of a nucleus in the atom. Number 1. Nucleus of an atom is positively charged. Nucleus of an atom is very dense, and third, the size of the nucleus is very small compared to the size of the atom. Now there is two diagram, Rutherford alpha particles, scattering alpha particles, the scattering of alpha particles by atoms of gold. Rutherford scattering experiment, this both, and drawbacks also. Drawbacks. The major drawback of this model is that it didn't explain the stability of the atom. According to the electromagnetic theory, if a charged particle undergoes acceleration, then it must radiate energy continuously. Thus, the revolving electron loses energy and falls into the nucleus. And the last point, that the atom would be highly unstable and hence matter could not exist in a form that is known now, but it is known that atoms are stable. Now, the first picture, the scattering of alpha particles by atoms of gold foil. Conclusion from the observations. Those observations were quite unexpected. He thought that all these alpha particles, after striking the gold foil, would come back since the atoms are extremely closely packed. Moreover, Gold is also a very heavy metal. We already have explained. However, he made the following conclusions from the experiment. As most of the alpha particle passed through undeflected, this means that they didn't come across any obstructions in their path. Thus, most of the space in an atom is expected to be empty. Second point, as a few alpha particles suffered minor deflection and a very few major deflection. This means that this must have made with some obstruction in their path. Third, these obstructions must be very small. Only a few particles were obstructed by it. Massive. Each alpha particle has 4u mass and is quite heavy. It could easily pass through a light obstructions by pushing it aside. And this is the next diagram, Ruderfort scattering experiment. Thank you all students for watching the video carefully and repeatedly to understand properly. Stay tuned for all video updates. Please comment for your doubtful questions in the comment box. I will make video for all questions raised by students. Please don't skip the video, else you will miss the important part. Please like, share and subscribe the video of the channel Agito Education. Don't forget to click the bell icon so that I can send you an intimation for my every latest video.